Hello and welcome to another episode of my C# Basics tutorial series using Godot. In this episode we will finally get to developing games, or at least we'll lay the foundation so that you'll be able to develop games. So in this episode we will create our player instance. From there I will explain you how the node system and the scene system work. So let's create a new scene. For that I create a new folder right here in our scenes folder. And I say player, and in there I will create the new scene player. Our player is a 2D scene, and of course our player has to have a sprite so that we can see him. A sprite is nothing more than let's say a texture that an object has in a 2D environment. In order to do that we have to do a right click on our player node, which we will by the way rename to player. You make a right click and say add child node, and in here we type in sprite. Now we have a sprite, but our sprite has to have a texture. We will create a new folder in which we store our sprites, call it assets, and in here we create a new sprites folder. For everyone who's watched my 1 hour GameDev video will remember this sprite. We'll simply drag and drop it into here, and here we have it. It's kind of mushy if you can see that. For that we will simply click on player, click here on import, and disable the filter right here, and click on re-import. So now we have our sprite. We can head back into our player scene and load this texture. Open. And here we can see him. Now we have to insert the player into our game scene. So the player is a scene by himself, just as our game itself, our game scene. And let's simply drag and drop the player right into it. And here you can see how everything works. This is called the node system. Our player himself is a node 2D. The player itself has the node sprite, and it's probably gonna get even more nodes. Right here we have our game node, a node 2D as well. And we simply dragged and dropped the player node into our game node, and with that we also dragged and dropped the sprite node into our scene. We can also do this programmatically, but we will get to that later. Now our player can also have a script, just like we did it in the second episode. I think it's of course gonna be a C# script again, and make sure that everything is right, that it's in the player folder, and that it is an uppercase player.cs, and we hit create. So now we can do the same as we did in our game class, but of course our player should be able to do so much more. We are now able to actually develop our game. This of course means that we can now override the following method. Public override void physics process. You can remove the call to the base method. So what does this method do? Well, it's called on every node, on every single frame, so to say. Not exactly on every single frame, I think, at least with physics process, as that is called every time the physics are updated. Parameter right here, float delta, is always passed from the engine, from Godot, and it tells us how long has it been since the last physics update. This is useful to make games frame rate independent, so that the speed is always the same, no matter how long the last physics update took. So for now, let's simply move our player a bit. Every node 2D has a global position, which is a class called vector2. And a vector2 works just like in maths. So we have a vector2 vector equals new vector2, and in here you have two values. So we have the x coordinate and the y coordinate. The positions of all objects are always stored as vectors. And of course you can add two vectors together, and you can of course multiply back with something like that. One thing we haven't discussed as of now, you see this f. This is because this is a float data type, and a float is pretty much the same as a double, but takes less storage and is therefore useful when developing games. It looks like this. There are of course a few differences, but we will get to them later on. Right here, let's simply move our player to the right. So we say global position, which is a vector, and we add another vector to it, x and y coordinates, as you remember, and we will set the x-coordinate of our vector to, let's say, 40 times delta. Always important that when you move something, it must always be multiplied with a delta value. So let's try it out, and we see that our player moves slowly but steadily towards the right of the screen. But of course, only having a move to the right of the screen is not a particularly exciting game. We can react to player input. For that, we have to define how our inputs are measured. So we go head into project settings, and input map. There are a lot of default settings. We can leave them like that. For now, we will simply say walk left, walk right, down, and walk up. And then here we had on plus keys W. No, not for left. So I always like to have in our scripts folder a class that is called input constants or something like that. And here we have public const string up. I guess we didn't talk about what const means. It's simply a variable that cannot be changed. Let's create our vector2. And this is called move. In this vector, we will store how our player is gonna move. Outside of this, we will create a float speed, which is gonna be 80. So now we can say flow position plus equals move times speed times delta. If input.isAction is pressed and we have our input constants walk up, then we know that the player has to move up, which is negative y. If we go further down, we increase our y value, and if we go further right, we increase our x value. So it has to be negative y if we want to go up. So let's say move.equals -1, that we move into that direction. If you remember, we multiplied with the speed later. And we say if input is action just pressed, put constant start down, then our y coordinate has to be increased. So now I would like to remove the just, because just is only executed where we press the button, but only once. And if is action pressed, it's gonna be executed all the time. What have we done here? We stored our vector move, in which we stored in which direction we want to move. And based on the input, we said it's either -1 or +1 on the x or y axis. And our global position is increased by move times speed times delta. Let's try this out. So you can see our player. And when I press the corresponding key, so WASD, then you can see the player is moving. Isn't that great? So let's recap what we learned today. We learned how to create scenes. We learned that everything is based on nodes. We learned that nodes can have child nodes, and then when you insert a node as a child node to another node, then the child nodes of the first node are gonna be inserted as well. We learned what vectors are. We learned what a float is. We learned how to use the physics process method. We learned what the delta value is. We learned how to edit the input map, and we learned how to move our player using vectors. In the next episode, I will show you how you can spawn other nodes and scenes using only code.